Hello, and welcome to the Making Medicaid Data More Accessible Through Common Data Models and FHIR APIs webinar series. Before we begin, I'd like to provide a brief overview of this project, which addresses the federal priority to expand data capacity or data infrastructure for conducting patient-centered outcomes research that informs decisions about the effectiveness of health interventions used in Medicaid and children's health insurance programs. The Transformed Medicaid Statistical Information System, known as T-MSIS, has analytical files that are suitable for research. As part of a new research-optimized national Medicaid dataset that begins in 2014 with full representation from all jurisdictions in 2016. These files include data on Medicaid and children's health insurance program enrollment, demographics, service utilization, and payments. This project created open source code to format these data into the FDA Sentinel and Observational Medical Outcomes Partnership common data models to improve data access, accelerate analyses, and enable multi-database studies. The aim of this webinar series is to educate researchers who are using or plan to use Medicaid data about the new data transformation tools and disseminate major findings. Each video in this webinar series is a chapter that covers a key project objective. My name is Nick Williams from the National Library of Medicine, and I'll be leading this chapter, Chapter 2, which discusses transferring Medicaid and children's health insurance program data for use with the Observational Medical Outcomes Partnership, OMOP Common Data Model. Please note that the views expressed in this presentation are those of the authors and do not necessarily represent the official position of the U.S. Department of Health and Human Services or the Food and Drug Administration or the National Library of Medicine. Let's review our agenda. We will discuss a project overview. We will discuss what is mapping. We'll engage with how mapping actually works. We'll review familiar examples. We'll reveal and share the method we used. And finally, we'll share some tips for the road so you can try your own mapping exercises. Towards project overview, TAF records are not designed to be used for observational research, but Observational Medical Outcomes Partnership records are designed to be used for observational research. The question then becomes how to transform TAF records into OMOP records to support observational research. As a quick definition, what is mapping? Well, mapping is translation and verification of information from one system to another. If two systems are communicating across data collection, storage, or transmission efforts, then some level of mapping is happening. We hold that a map is a relational statement between two information systems that supports interoperability between them. The act of mapping makes maps. A map should exist for an intentional use case. Not all maps do all things. They have a low reuse value. A map should support an essential activity, as mapping is expensive and it takes a really long time to do it. A map should also be assessed for information gain, information loss, and error or bias introduced by the act of mapping. A map should not include a one-to-one relationship except in very strange and intentional circumstances. A map should not be more stable than its parents. If the table structures of the information systems that are being mapped change a lot, the map should change as well. A map really should not be made arbitrarily. The map should really support hardware and software systems with known constraints and opportunities. So a map tells a coder, and eventually a computer, what from information system X is what in information system Y. Information systems have a class anatomy to them, and most of these anatomies look like this, where information systems contain tables, and tables contain items, and items contain responses. Note mapping information systems happens at multiple levels, at a table-to-table level, at an item-to-item level, and at a response-to-response level. You may be thinking that sounds a lot like item response theory, and you guessed right if you guessed IRT. IRT is a large group of models or instructions that explain how to discover underdocumented facts within documented facts, often in information systems. Similarly, the analysis you will attempt to do with your mapped data is likely insights production, which is the discovery of underdocumented facts. And you're going to discover those underdocumented facts from data reuse activities with documented facts. So how to map information system TAF to information system OMOP? You might consider doing this at table level and answering the question, how many candidate tables are there in each system? You might further develop this to ask, how many candidate items are there? So at item level, for each heading or item, how consistent is that declaration? Is it stable or not? Further, you should consider, what are their table item distinct pair counts? Now, TAF has about 1,850 distinct table item responses versus 650 in OMOP. So when considering candidates between TAF and OMOP, there are 1.2 million candidate pairs, and you need to evaluate them to complete your map. Finally, at response level, here you should just use Athena, which is a terminology relatedness database. Athena will support you as long as the responses you're mapping are controlled terminology responses, such as ICD-10-CM or SNOMED-CT, and many more. Each information system then has a table item response relationship. So it's just a matching game, really. Remember to play the game for recall, play for kinds of error avoidance, play for assets to support specific use cases that you know your information system should support. Be sure to collect requirements and manage expectations. And finally, remember, mapping usually means information loss, or there will be information in TAF that just doesn't fit in OMA. Let's look at some familiar examples. There are a lot of information system table item response relationships that you see all the time. Your tax return is a great example of this. You might consider an information system called the IRS master file, inside of which might live a table called Form IRS for 1040 with the tax year. You might consider an item on that form called gross adjusted income, and finally a response of $0. Further, you might consider an information system called Medicaid, with a table or form called CMS Form 1500. These are literally those forms. From the left-hand side, you can see a 1040 for 2023. If you don't use TurboTax and filled this out by hand, this is what the items and responses would look like. Further on the right, in the red salmon color, you can see a copy of CMS Form 1500. These look like surveys. And I want to remind you that using item response methods for mapping is a great idea because on some level, TAF is a gigantic survey, and so is the IRS master file. So how does this work? How do you discover what in system number 1 is what in system number 2? Now, we've touched on a large volume of candidates and trying to get through them in some sort of quick manner. But before we get started mapping candidates, it's important to think about kinds of assignment. Whereas the assignment of candidate 1 to candidate 2 arbitrary? Is it automated? Is it asymmetrical, by which I mean we can go from 1 to 2, but not from 2 to 1? You also should think about if the assignment is stable over time, if it is structural and consistent across all eras of those information systems, and further, is it sufficient for your specific use case? Just some things to think about as you evaluate candidacy. Towards the method we used, we did something called hierarchical characterization of target and source information system data dictionaries. We did this by data type and domain. An example of some of these hierarchies included clinical, which meant diagnostic procedure and medication codes from controlled terminologies, dates, financial detail, place detail, provider detail, and subject detail. This is a few examples. Now, what you might do is take your data dictionaries and you might pre-map them to these hierarchies. And it's pretty straightforward. A date should look like a date, regardless of how you might classify that date at a deeper specificity level. You then should draw candidates for dates from your destination system, from your origin system, by restricting to the dates themselves, because the dates will be the candidates for the dates. This effectively shrinks the canvas by making multiple canvases and will radically speed up your mapping exercise. Here is a real-world example from an actual data dictionary we annotated like this. This is from the Taft Dictionary. You can see this is from Taft Demographic and Eligibility Enrollment Tables. And you can see that some of these rows were declared under a class. Bear in my initials, I actually mapped this. And you can see that age and age group were mapped to subject. It's a fact about a person who's receiving care. You can see Benny County Code was actually a place category or class. And there are a few others, including meta. So the date that Chronic Conditions Warehouse loaded the table into the VRDC for us to use, there's a date there and it was marked as meta. So you can think about how drawing candidates within these super hierarchical categories might be helpful. So how to think about the problem then? At each table item response level across information systems, is this a one-to-one match? Is this a one-to-many candidate match? Is this a sum-to-some or sum-to-all match? And a good example of this is in TAF, where you will declare a birth date for a beneficiary, versus OMOP, where you will declare a year of birth, a month of birth, and a day of birth for a beneficiary. That would be a one-to-many match example where I can calculate those fields from birth date pretty easily. So in this way, you might start to think about matching candidates and classifying them on their completeness, either left to right or right to left. Further, you can consider if you need to compute an item and response, or can you pull directly from the source information system without making any changes? And in the case of, full date of birth to birth month, birth date, birth year, you would need to do a calculation, but it's pretty straightforward. There are obviously more complex examples than this. Finally, we took a matrix approach. Now, I can't overemphasize how valuable this is. So for each distinct table item pair, retain one expression per information system, and then evaluate each pair for candidacy. So for example, within the other services month year TAF table, there is an item called ICD DGNS-CD1. And you might ask, is that a match for a table in OMOP called condition occurrence and an item within there called condition source value? Now, if it is a match, you could actually use that information to inform future matches. For example, there are many DGNS CD2s and 3s and 4s. There are many diagnosis codes on a TAF claim, actually, lots of them. So that information might be really helpful if you were further trying to evaluate if DGNS CD2 also goes to condition occurrence and also goes to condition source value. Towards a more complex issue, you might think about, does Benny ID equal person ID across all tables? In that case, it really doesn't. Finally, for some tips for the road, use a matrix approach. Here's a great example where you can see our TAF tables in the first two columns with item and response, or sorry, just item, table and item rather. And then across the top, you can see a matrix for our OMOP destination tables. And in red, you can see which beneficiary IDs go to which common data model destination CDM tables. And it's not all to all. It's a sum from here go over there. For example, for inpatient header Benny ID, that's actually going to go to visit occurrence, procedure occurrence, condition occurrence, observation, and measurement, but will not be used as a Benny ID for drug exposure because inpatient drugs are pretty unusual on TAF claims for various reasons. Tip number 2, consider classes of items. We touched on this with hierarchical mapping. So an item-to-item classable map might speed things along. How many kinds of information are there and which tables hold them is a good question. For example, which tables have clinical items? Which tables have financial items? Which tables have demographic items? Which tables have location items and dates? Maybe half of the items in TAF are really financial items. Consider limiting yourself to 10 hierarchy classes, although you could do more if you wanted to. By mapping the table items to classes across information systems, you can limit the candidate pool to within class items or items of a shared hierarchical class. Then you just have to reconcile the unmatched and unmapped ones. Further, if there are ties, you need to do some decision making. And that's map. Towards tip number 3, controlled terminology is your friend, and not everything in TAF is a controlled terminology code. But if it is, you can use Athena to resolve your response mappings. And examples of controlled terminology codes found in TAF include ICD-9CM, ICD-10CM, HCPC, CPT4, NDC codes. Mileage is going to vary because a non-trivial fraction of procedure codes in TAF are not controlled vocabulary codes, including state-specific procedure codes from Romney Care, Ohio Medicaid, home health aid codes, many more. Many states have custom procedure codes that won't be in Athena. There are also T-MSIS error codes, which are specific to T-MSIS as well. Finally, tip number 4, source terms might not be irrational. This is a great tip. So see how Benny ID and provider ID in TAF are both postfixed with ID? If I'm thinking of a hierarchy class to put them in, they might go under identifiers. Similar admission date and procedure date, those are real item names in TAF. Both are postfixed with DT. They're both dates. How does TAF or does TAF have an item taxonomy in postfix of name that can help with rapidly discovering what item is what in what hierarchy? And the answer is mostly yes. It works pretty well. So thank you for your interest in mapping. If you'd like to learn more about making Medicaid data more accessible through Common Data Models and FHIR APIs project, follow the link shown in the description field below. Links to other presentations will be included in the description field. Additionally, all webinar chapters can be found in our YouTube playlist. Thanks, everyone.